Hey class, today we're going to be solving one-step inequalities. So we're going to start by reviewing how to solve a one-step equation. So we need to remember that we solve these equations with our inverse operations. Our goal is to get our variable by itself. So for the first one here, we have an x minus 2 equals 3. If we want x by itself, the minus 2 is just like having a negative 2. And the inverse of minus 2 or negative 2 is to add 2. But we want to keep the equation balanced. That's why I put the line here. That reminds me that I have two sides to an equation. So whatever you do to the left, you must also do to the right side. And then simplify here. Negative 2 plus 2 is 0. So on the left side, I just have x left, which is what I want. I'll bring my equal sign down. And then 3 plus 2 is 5. So my answer for x is x equals 5. Remember, you can always plug it back in. It was x minus 2 equals 3, so 5 minus 2 equals 3, and that does work. So I can always check to make sure my answer is correct by plugging it back in. Number 2, x plus 5 is equal to 9. Similar to the last one, but this time we have a plus 5. The inverse operation of adding, or the opposite of positive 5, is negative 5. So I'm going to subtract 5, doing that to both sides. On the left, I'm going to be left with just my x. 5 minus 5 is 0, equals 9 minus 5 is 4. So x equals 4. If I can check that, 4 plus 5 does equal 9. In number 3, 3x equals 12. That means that this says 3 times x equals 12 when it's written like that. So the inverse operation of multiplication is division. So I'm going to divide both sides by 3. Because 3 divided by 3 equals 1, so we're left with just x, and 12 divided by 3 is 4. So x equals 4 is our answer. And I can double check by plugging 4 back in for x. 3 times 4 does equal 12, so I have the correct answer. So we're going to be solving inequalities like that today. So I wanted to review the inverse operations. Now I want to write a compound inequality that matches the graph. So just a little bit more review of what we've been working with. When we have inequalities that are facing different directions, this is an OR inequality. So it's going to be separated by the word OR. You're going to write each side individually. This side, I have all of my x's are to the left of 10, and it's an open circle, so it's not including 10. So this one represents x is less than 10. So not equal to, not including 10. This one, the x's, the line is all to the right of 20. And 20 is not included, so these x's are all greater than 20. And then we write the OR in between because this is an OR. X is less than 10 or x is greater than 20. This one's similar, but it looks like we're counting here. This would be at negative 3. It's an OR again because we're going two separate directions. The left side, we're at negative 3. It's included, and then all the values that are less than, so it's less than or equal to negative 3. Or then we're at 6. 6 is included, and then all the values greater than or equal to 6. So x is greater than or equal to 6. When you're writing these, make sure you put your inequality on the left side, or your variable on the left, and then the number on the right, which we'll review in a second. Whoops. All right. And then we have the AND inequality. This time the x's are between, including 18, but between 6 and 18. And so we're going to write this one. I'm going to start with the left side, and I'm going to have x is less than 6. That describes this part right here. We're at 6 and then less than. And then I'm going to add the other side. When you write a compound inequality like this, you want it to be written together. So your inequalities are going to face the same direction. So I'm going to point to the 18. 18 is smaller than my x in this case. So I'm pointing to 18. X is the bigger one. And then 18 has a closed circle, so I'm going to add the equal to. So this should read 18 is less than or equal to x, and x is less than 6. So 18 is less than or equal to my x's, and x is less than or equal to 6. So that's how that is read. Okay, we're going to just do addition and subtraction mostly today. And so just reviewing addition and subtraction properties of inequalities. when adding or subtracting the same number on each side of an inequality, it produces an equivalent inequality, which means that if you have A is less than B, if you add the same number to both sides, it stays less than. Or if you subtract the same number to both sides, it stays less than. And same for greater than. So you can add or subtract to an inequality on both sides, and you do not change the way the inequality is facing. So our first equation here is m plus 9 less than or equal to 12. I just rewrote it so that I could have a little more space. Similar to when we solve the equation, we want to use our inverse operations to get m by itself. So if I have m plus 9, the inverse of adding 9 would be to subtract 9. We're going to treat this like an equation, so there's two sides here, the left and the right. So if I subtract 9 from the left, you also have to subtract 9 from the right. So then we have m.
All students in the building need to be in a classroom. Teachers, please.
12 minus 9 is 3. So we end up with m less than or equal to 3.
Thank you.
So then we can graph that. 0, 1, 2, 3, 4, 5. And it's less than or equal to, so we'll have a closed circle at 3. It's including 3, and then less than would be to the left of 3. Okay, don't forget, inequalities, order matters. You really want it to be written with the variable, then the inequality symbol, and then the number every time. So we want the variable on the left side. But sometimes when we're solving, we end up with the variable on the right, or we end up with we're given a problem with the variable on the right. If this happens, we want to flip it around so that we graph it correctly. So if we start with the variable on the right, we want to rewrite it so the variable is on the left. Notice that the inequality is pointing at the x. When you rewrite it, you have to flip the inequality around and keep it pointing at the x, and then put the -3. So let's try that again. This one, the x is on the right. I'm going to move the x to the left, which means I need to keep the inequality pointing to the 4 like it is currently. So I'm going to flip it around and then point it at the 4 again. So 4 is less than or equal to x is the same thing as x is greater than or equal to 4. One more time. 5 is less than x is the same thing as x is greater than 5. So if you flip, and the flip-flops are kind of a helpful reminder, if you flip-flop the inequality around, so you flip the number and the variable, then you must also flip-flop the sign. Inequality sign. There we go. So let's look at a few more examples. So here's an example where we have 15 is less than or equal to x plus 9. So our variable's on the right side instead of the left, and that's okay. I'm going to solve it the same way still. I'm going to look at x plus 9. I want to get x by itself though, so I need to get rid of the plus 9. The inverse of adding 9 is to subtract 9. So I'm going to do that to both sides. 15 minus 9 is 6. I haven't adding and subtracting doesn't change the inequality, so that will stay less than and come straight down. And then we got x left on this side. It's before I graph it, I'm going to flip the x and the 6, and if I flip-flop those numbers, then I also have to flip-flop the inequality, so it's going to become greater than or equal to. So if x is less than or equal, or 6 is less than or equal to x, then x is greater than or equal to 6. And then I can graph that 4, 5, 6, 7, 8. It would be a closed circle at 6, and then we would go to the right. Then you can check your answer if you'd like. You could plug in anything that you've graphed just to make sure you have it graphed right. Is 15 less than or equal to, let's try 7 as a solution. 7 plus 9. 15 is less than or equal to 7 plus 9 is 16. 15 is less than 16. So I have graphed it correctly. And it helped to graph it correctly. It helped to flip it around. All right, x minus 24 is greater than or equal to 21. So on this one, I am going to get x by itself here by doing the inverse of minus 24, so adding 24 to both sides. And I get x is greater than or equal to, it'd be 45. I have my variable on the left. I do not need to flip it around. There's no other steps here, so I'm going to start at 30 and count up to 50 by 5s, just so I can get a nice range of numbers on my number line, and 45 is in the middle. And then it is a closed circle because we have equal to, and then it says x's are greater than or equal to 45, so you'd go to the right. All right. This one is 10 is greater than or equal to negative 3 plus x. So I can solve this still, even though that the variable is on the right side. I just want to get the x over here by itself, so I need to get rid of this plus negative 3. Well, the opposite of adding negative 3 is to add positive 3. So I'm going to do that to both sides. Then 10 plus 3 is 13. Adding doesn't change my inequality, it'll stay there, and then on this side I have left x. So the only thing I want to do now is, since x is on the right, before I graph it, I'm going to flip this around. So I'm going to flip-flop the x and the 13, which means I need to flip-flop the sign. So instead of greater than, I'm going to have less than or equal to. 13 is greater than x is the same thing as x is less than 13. So I flipped around the numbers. I need to flip around the inequality. It's pointing to the x here. It needs to point to the x here as well. So that would graph very similar to our last couple of examples. Whoops. 12 comes after 11, then 13, 14, 15. This one would still have a closed circle at 13 and then less than. So if you're questioning your answer, you can always plug it back into the original and make sure that it is a true statement, and that, so pick something in your solution set, any number that you have graphed, plug it back into the original and see if it gives you a true statement. That can tell you that you have it graphed correctly. And one more. This one says 2 times x is less than 24. So similar to when we solved our equation up top, this inverse of multiplying by 2, sorry, I can't talk all of a sudden. The inverse of multiplying by 2 would be to divide by 2. So we'd divide both sides by 2, because 2 divided by 2 is 1. So we get x. We divide by 2, we do not change our inequality sign, is less than. 24 divided by 2 is 12. So x would be less than 12 if 2x is less than 24, which means I could graph this. Let's see. 10, 11, 12, 13, 14. This time it is just less than. There is no equal to sign below. So I'm just going to have an open circle at 12, and I'm going to be going to the left for that one. Okay, that's all I got for you today. Thanks for watching.